All right, we're going to do our last topic for this unit, and we're going to look at inequalities. Today what we're going to look at are inequalities in one variable and inequalities in two, and then in our next lesson we'll look at systems of inequalities. So to start with, an inequality is just basically using a less than or greater than symbol instead of an equal sign. So in Math 10 you would have done some of these kind of questions where if you had something like x is greater than 3, on a graph, we represent that as an open circle pointing to the right. If you had x is less than negative 7, open circle pointing to the left. And if it's greater than or equal to, we use a closed circle or a colored in circle. So to solve these things, basically anytime you get an equation in one variable, we want to solve it just like a regular equation. So today we're just going to look at just linear ones, and we'll do quadratics later on. So with a linear equation, solve it just like you normally would. So we'd add 1 to both sides. So you'd end up with 4x is greater than 7, or greater than 8, divide by 4 on both sides, and we get x is greater than 2. So that's where we put it on our number line, because it's greater than, open circle, pointing to the right. Okay, so that's pretty easy. So open dot for greater than or less than, and a closed dot for greater than or equal to or less than or equal to. And then we just point the arrows left or right. So if you always write your answer as x first, that that symbol, in this case it's less than, you can kind of see it's sort of like an arrowhead pointing to the left. So in this case we'd have a solid dot at 5 pointing to the left. Okay, so let's do a couple more. So in this case we bring the 1 over to the other side. So we'd have minus 2a is less than or equal to 4. Now if we divide by negative 2, you'd have x, or a is less than or equal to negative 2. The trick is we got to be really careful with the negatives. So if we graph this one, we'd have everything less than negative 2. So it'd be a solid dot pointing to the left. But if we actually plug in that number, so if we try a number like negative 3, we plug that back into the original, what we see is it actually doesn't work. We'd have 1 plus 6, so we end up getting 7 is less than or equal to 5, so that doesn't work. If we try one on the other side, let's try like 0, we'd have 1 minus 2 times 0 less than or equal to 5. That one does work. So what happens is it ends up being the opposite. So the trick is, or what you have to remember is when you divide by a negative number, you have to flip the inequality sign. So our correct answer should be a is greater than or equal to negative 2. Okay? And that's the only time you got to be careful is if you have a negative in front of your a or your x or whatever it is, and when you divide by that, you have to flip that inequality sign. Okay, so if we get two variable ones, so the similar kind of things apply, except we got a y now, so what we want to do is solve these just like we do with a normal linear equation. So let's get this to be y equals, so we would bring the 2x over, so we'd have minus 2x plus 6 on the right side, and we want to divide by negative 3, so we'll divide everything by negative 3, so we'd have y as less than, we divide by negative, so we've got to flip our symbol, 2/3 x minus 2, so that would be our final graph. So now to graph these, you can put these in on your calculator, just type in y equals 2/3 x minus 2, it would give you a graph something like that. So the only thing that's different with graphs is it's not equal to would be the line, we want less than or equal to. So just like we do our open and closed dots, we use a solid line if it's equal to, so which it is in this case, and we want to do everything less than the line. So in terms of a graph, everything less than the line would be the entire area below that line. So we actually just shade in the whole bottom portion of the graph. And that's it. So for less than or greater than, instead of being a solid line, we draw it as a dotted line. And then greater than or equal to or less than or equal to is a solid line. And then if it's less than or equal to, we shade below. And if it's greater than or equal to, we shade above. And that's really the only thing that's different from a normal graph. So solve it equal to y. So let's do this one again. Let's bring the 3x over, so that makes it minus 3x. Divide by negative 2, we'll flip our symbol. So So when we divide by negative 2, we get plus 3. So our graph in this case would be 3/2 x plus 3, so it's going to be a line something like that. It's greater than or equal to, so it's a solid line, and greater than we shade above. So that would be our graph. We get a question like this that says, is negative 2, 4 a solution to the inequality? So if you actually have it graphed and you look for where the coordinate is, so negative 2, 4 would be somewhere up there. That point you can see is in the shaded area, so we should say yes, right? It's in the shaded area, that is a solution. Or mathematically, we could just plug it into equation, go back to our original, plug in negative 2 for x, positive 4 for y, and actually see if it's true or not. So you'd have negative 6 minus 8, so that's minus 14. Is negative 14 less than or equal to negative 6? Yes, it is. So we are right. Based on our graph or based on the equation, they both are true. So let's try another one. So here we got y is greater than x squared. So this is a quadratic, but just like any other graph your quadratic. So we'd have x squared plus x plus 2, so it'd be an upward quadratic going through 2. And I'm not sure exactly the shape or the location, but it really doesn't matter in terms of the graph. So there's our graph, something like that. We want greater than, so if it's a quadratic, that means it's going to look like that, but we have greater than, so it should have been a dotted line. So let me erase some of our line here. So it should have been a dotted line, not a solid line. That would have been the first mistake. And then the second thing is we want shaded greater than. So in terms of a quadratic, it's tough to think of it as above or below, but imagine straightening that quadratic so it's like a bowl or a plate. The greater than part would be the top side of the bowl, so it would look something like that. Okay, let's try one more. So here's another quadratic. We want less than or equal to 3x squared. So in this case, we'd have a graph that would look, it's going through 4, positive, so it'd be something kind of like that. Solid line because of the equal to, and in this case we want to shade below, so that'll be everything below the bowl or the quadratic shape. And that's it.